Amalanathan, sir. Hello. Could you hear me?
Yeah, tell me, sir.
Sir, did your principal join?
Yeah, today instead of our principal, one madam is representing. She
Okay,
already joined.
Okay, then we can start, sir. You can
Okay.
take over. Yeah, please.
A very cool good evening to everybody. Respected Secretary of Nanjil Catholic College of Arts and Science, respected Principal Dr. Meenakshi Sundararajan, distinguished Chief Guest, dear participants. Once again, a very good evening to everybody. I am Dr. Amalanathan, HOD, Department of Physics, Nanjil Catholic College of Arts and Science. Today, the Department of Physics, Nanjil Catholic College of Arts and Science reach another milestone. That means today we are organizing a 6-day hands-on training on COMSOL multiphysics. In this special occasion, it is my pleasure to welcome those who gathered here. First, I take this opportunity to welcome our Secretary, Reverend Father Recurrence Michael and Dr. Meenakshi Sundararajan. They are the people who behind the growth of our college. They also always motivate to our department to organize such a wonderful program. So on behalf of you all, I really welcome our secretary and our principal. Welcome you, Father and Principal. It is my pleasure to welcome Dr. Shushma Jennifer, who representing the principal. She is the head of the Department of English. She is the energetic woman in the campus also. On behalf of today, she is going to inaugurate the session. So on behalf of you all, I welcome Dr. Sushma Jennifer. Welcome you, madam.
Thank you, sir. Thank you so much.
I extend a very warm welcome to the resource person of the 6 days program, Dr. Jitendra B. Maurya. He was assistant professor at the Electronics and Communication Engineering Department, National Institute of Technology, Patna, India. She is a wonderful resource person in India. She organized so many programs like that.
Hello.
We are very pleasure to such a wonderful chief guest as a resource person for this webinar. Sorry, for this hands-on training. Welcome you, sir, on behalf of our college.
Thank you, sir. Thank you for my introduction here.
Yeah, I express my sincere thanks and welcome the organizer Dr. Hijaz, CEO, Spark Institute of Advanced Science.
Thank you, sir.
Recently completed his PhD in NIT Trichy. So on behalf of our college, I welcome you, sir. Also, welcome you, sir. Finally, I welcome all the participants who are joined for the 6 days hands-on training program. On behalf of the Department of Physics, I wish all the participants, those who participated. Welcome you all. Thank you, one and all. Next, I invite Dr. Shushma Jennifer, HOD, who representing the principal of Nanjil Catholic College of Arts and Science, to deliver the inaugural letters. Welcome you, madam.
Thank you, Dr. Amalanathan. A very good evening to you all. I'm Dr. Sushma Jennifer, head of the Department English at Nanjil Catholic College of Arts and Science. Indeed, I'm really happy and honored to inaugurate the 6 days hands-on training on COMSOL Multiphysics program for our upcoming young scientists. On behalf of our principal and secretary, Reverend Father Recurrence Michael, this program is organized by Nanjil Catholic College of Arts and Science, Kariyakavalai, and in coordination with Spark Institute of Advanced Science, Calicut University, Kerala. I must congratulate the efforts of Dr. Amalanathan, head of the physics department, and the IQAC coordinator for arranging this wonderful training program on COMSOL multiphysics. The full-fledged Department of Physics at Nanjil Catholic College of Arts and Science has been exhibiting spectacular scientific insight into the world of technology. It is furnished with 3 separate labs for undergraduate program, post-doctorate, pre-doctorate, and doctoral programs also. A student who enters into a college for an undergraduate course can step out of the college as a scientist with a doctorate degree. The physics department is enhanced with a team of determined and dedicated staff with a doctorate and high academic accomplishments. They cannot be restricted with the title of professors because they are all scientists who build their knowledge on attentive observations, measurement, systematic analysis, and carefully designed experiments. They provide quality research in the world of physics through various research projects undertaken by the PhD scholars and also the faculty of physics. Now, the development in technology is synonymous with the advanced physics. The microscopic or macroscopic advancements are inevitably unavoidable for the development of our nation. And the mission of physics teaching is not only to convey practical skills and knowledge, but also to contribute knowledge, education for wisdom and responsibility. In our country, now we are in need of scientific development and technological upheaval to stand and fight with all the massive structures of the developed nation. COMSOL Multiphysics is a comprehensive simulation software environment for a wide array of applications structured in a user-friendly manner. And I am not the right person to speak about multiphysics because in our forum, we have the most eligible gentlemen like Dr. Amalanathan of Natural Catholic College and Dr. Jitendra Maurya of Assistant Professor of Electronics and Communication Engineering at NIT Patna to enlighten us on these 3 days of handsome training on COMSOL Multiphysics. I wish all the very success for the coordinators and congratulate all the participants for enrolling yourself and taking part in this training program. I really request you all to attend all the sessions without fail and make the maximum use of it. I officially inaugurate this training program on behalf of our principal and secretary, Reverend Father Eckermans Michael. I wish you all the very best. Thank you for your time.
Thank you, Madam, for your nice inaugural address. Next, I invite Dr. Hijaz, CEO, Spark Institute of Advanced Science, to introduce the program and to introduce our chief guest. Welcome you, sir.
Thank you so much. Thank you, Amalanathan sir, and thank you, Dr. Sushma, for being here and for your wishes. So I will introduce our organization, CR's Research Forum. So I hope you all can see my screen, right?
Yes, sir. It is visible.
Yes,
Yeah.
visible.
Thank you so much. So basically, our institute, it is Spark Institute of Advanced Science. We started by giving academic courses like coaching for different competitive examinations. So first we gave a coaching on air traffic controller examination of Airport Authority of India. We also give coachings for Central University PG entrance, physics, chemistry, and maths, and for IIT joint admission test for MSc in IITs for different subjects like physics, chemistry, and maths, and GATE, etc. So these are the things that we were started with, and right now we are going to launch courses on IIT JAM coaching in October, both in physics and chemistry. Right now we are not doing it for maths. For this year, we will be doing it for physics and chemistry only. And maybe this would be a good news which is useful for the students in Nanjal Catholic College. Maybe you can share this news with them that we are going to start a coaching for IIT JAM physics and chemistry. Basically, we are not only an academic coaching institute, we are also interested in research. And we have this under the umbrella of CR's Research Forum, we do a lot of research and training activities. So we give membership in our research forum to faculties and students. So once they are a member, they can network each other and they can collaborate in our research and training programs. They can host programs in their colleges. So this is how it works. So we collaborate with different academic institutions and also with industry partners. I will showcase some courses which we have done so far and some of the courses which are coming in the near future. So these are the courses that we have just finished up. So we started with a 7 days hands-on training in Chemdraw and Chemsketch. And in this program, we had people from Perkin-Elmer, USA, they participated, and we have people from the Chemsketch software as well. After that, we conducted a faculty development program on online chemistry teaching. We had international participants from different countries in this faculty development program. And after that, we conducted a program on hands-on training on rate-while refinement using foolproof GZAS and also YANA software, using YANA software. So we had eminent scientists from different organizations as our resource person in this program as well. We also gave a orientation program for KVPY examinations to encourage young students towards science. And right now, a 1-month Python coding program for beginners is going on. This is being done in collaboration with Ramzadeh College, West Bengal. So it is a college of one of our forum members. So they hosted the program, and this program is going on. So it is a 1 month, 30 sessions. So far we have finished 19 sessions of the program. And the 5-day workshop on elemental analysis. This was the last program that we conducted. It was 2 weeks before, and this was hosted in PSMO College in Kerala. Now, so right now, today we are beginning this COMSOL multiphysics hands-on training. This will go to next 6 days. And immediately after that, from 1st of October, we will give a training course on basics of stock market. So this is something different. Stock market course is besides science, that is what we are doing. Like the first course out of the science domain, science and engineering domain. And after that, there will be a course on advanced molecular docking. So the registrations are open for this particular course on advanced molecular docking, which will be happening on 16th of October. It will be a 7 days hands-on training program. We have resource persons from Manipal University and from another college. And there is another training program happening on Origin software. Again, for this program also, the registrations are open, which starts from 1st November to 5th November. So it will be a 5 days program. And after that, we will be conducting a program, nearly a 20-25 days program on DFT calculation, workshop on hands-on training on Gaussian software for DFT calculations. Then there are some other upcoming programs like training on EndNote and Mendeley, and also a hands-on training in LaTeX. So these are the upcoming programs. So maybe some of you may be interested in our courses which has been already done, like Chemdraw, rate-while refinement and all. So if anybody of you wish to get access to these courses, the recording of all these courses are available. So you can get an access to them. So anybody of you are interested to get an access, you can email us to sparkinstituteofscience@gmail.com. You still have the opportunity. And so there are different membership options in our research forum. You can join as a student member or as a faculty member. So once you are joining us as a member, then as I already mentioned, you will get of course financial benefits on our courses. You will get different reduction patterns on course fees and all. Moreover, that you will have a great opportunity to connect with people who are working in your field. And one important thing is that you can share your ideas in our platform. So everyone will be an expert in their own field. So if you wish to share your ideas, if you can make a course, and if you wish to be a resource person, you can join with us. Another opportunity is that if you are a faculty, you can host different programs that we conduct in your college. So that can be beneficial to you and also to the college and also to the students in the college. So we recommend all the people who are participating, or if you are looking for these kind of courses, if you are interested in engaging with the scientific community, and if you're interested in conducting programs, please be a member of our organization. That would be a great opportunity for both of you and us. So these are some colleges with them and industry partners with them we have collaborated so far. So one is PSMO College. We conducted 2-3 programs there. In MES Ponnani College, we conducted the faculty development program. Ramzadeh College, they are hosting the Python coding program now. And we also collaborated with Amarda Virtual Lab and Perkin-Elmer USA in our earlier courses. So we are also interested in doing not only in training, we are also interested in independent research. We also act as a research consultancy. So we are giving different services as like ritual refinement and on various spectroscopic analysis and computational analysis. So like if you want to do some particular analysis, for example, ritual refinement, and if you find that it is too time consuming, you can send us the sample, not the samples, you can send us the data. We will analyze your data and we will send you the results. So these kind of things are going on. And also we have a publication wing. We do publish science books. So if you are interested in writing science book chapters, you can get in touch with us. So these are the things that we do. This is what our organization is. And so I will talk about today's program on COMSOL Multiphysics, where we have Dr. Jitendra Maurya from NIT Patna. He was very kind to accept our invitation and to take this responsibility of giving training. So today, actually, some of the participants has contacted us regarding the installation process. Some of them are a bit confused about the installation process. So I would request them not to use this time, like not to use the time of the lecture for clearing installation doubts, because it will be time consuming. It will consume our time for no reason. So maybe you can contact us through WhatsApp after the class, and maybe Dr. Jitendra will give a brief explanation on how to do the installation. But still, if you are very confused, you can contact us through WhatsApp. That would be great, so that we can save some time. So that's it. So thank you so much, Dr. Amalanathan.
Thank you, sir. So now I invite Dr. Jitendra Kumar Maurya for delivering the lecture. Welcome you, sir.
Thank you, sir. And yes, business is doing very well along with this institute, that is the Spark. Actually, it is sparking the society, starting from the computational training programs like the preparation of IT, JN et al., JN students. And then after doing some training programs like this, which we are going to start, and after that, that is the research level facilities they are also providing, and also for the publications like the science books. And so these are the very, very good work. Right? So I wish that this institute will grow, right, at the highest height of it. Right? So with this, I should start my talk from here, and what is COMSOL and what is its different applications and how we can start it from very basic. Right? So I will go through the very basics. If you once know the basics, right, you can do by your own to the advanced level. Right? So, but as Mr. Hizas has told that some participants are facing problem in the installation of that software, which the link he has provided. And for that, I want to say that a small video is given in that link, and you should follow that video. That video is of the 2 minutes only. It will give you an idea how to install that. That is a very easy installation. After the downloading of the file, one problem is there only to extract that file. So you will be needing an extraction software, and like the WinZip can be there. And as usually you have, you are also using that particular software to extract any zip file. Right? So after the extraction, that all things is very, very easy. Right? You can do that. If it is not possible, you can contact me and also to the Mr. Hijas. Right? So shall I start, sir?
Yes, sir, sure.
Yeah, fine. So for that today, let us, I'm starting with some introduction regarding the COMSOL here. Let us see what is this. So if I say, let me first share my screen icon. I hope that my screen is visible to all of you. Is it?
Yes, sir, yes.
Fine. Okay. So, sorry, it's sensitive. Please wait. The board is much less sensitive. It is drawing a line without any typing there. Okay, ignoring that. This will work. Really like this button. So if we talk about the COMSOL here, and actually, if we know that there are several numerical methods.
Sir, sorry for the interruption. Sir, there is a little distraction in the voice. So could you try removing your headphones? Maybe that would be.
Yes, maybe. Is it not clear?
Yeah, it's better. It's better. Yeah.
Okay, fine. So if we talk about the COMSOL, and so we know that there are different yes. Please wait. Actually. My writing pad is not working. I should say it earlier. So I want to say that there are several numerical techniques through which we can model a problem, or we can see that we solve it. Right? Like you have heard about the transfer matrix method, maybe, or the Rangaputta method, and or Newton-Raphson method. These are the numerical techniques to solve the problems. Like the Muller method is there. Right? So these are basically the numerical techniques through which we can solve our problem by giving us an initial guesses there. Okay? But here, for the very huge software, and there are number of another numerical techniques they apply on the depending on the boundary conditions. And as we are going to make any device, okay, there can be different materials, and because of the different materials, any of the two adjacent material will have a boundary. And so what will happen if any energy is passing from one material to another material? So there are well set of rules of the boundary conditions, which I think if one is belonging to the physics domain, okay, he has covered the electromagnetic field theory. Right? In that we have studied the boundary condition. Right? So properties of the energy change when it passes from one material to the another material. So in that sense, there are different numerical methods like FDTD. You have to think about the frequency domain, frequency difference time domain method, and second is the finite element method, and one is the transfer matrix method. Another can be the another are also possible, but I want to say that the COMSOL is based on the finite element method. Right? So this is a method and to solve the structure. What COMSOL does in it is, suppose that you have a huge structure, right? So directly considering one material as a single, it separates it, divides it in several materials, means several sections. It basically separate in a small sections of that particular material, and at each section it applies the boundary condition. Right? So due to which what happens, the exact distribution of the energy we have finally. And we will observe this when I will be introducing the mesh there in the COMSOL. Right? So so at this we can shortly say that the COMSOL is a finite element method. And second, if we say that what is the system requirement for this software? Actually, at least you should have the 2 GB RAM, at least, for running the basic structure only. Right? But what I experienced that, okay, 8 GB is not sufficient at least. In fact, 8 GB is not sufficient to have a very good results there. So if you have your system, and so try to have it with 16 GB for having a faster response, and with some SSD also there, solid state drive in case of the hard disk. Then your hybrid mode is also can be compatible like the hard disk and the SSD also. So 500 GB SSD and 16 GB RAM, right? That will make your system faster to be compatible, to be have a faster response for the COMSOL results. Right? So let me start with the COMSOL. Right? Now, right. So here I have installed it. Right? I'm opening this one. If you install with the by default settings, you will get 2 icons on the desktop. Right? So one is the COMSOL multi-physics here you can see, and second one is the here COMSOL multi-physics with MATLAB. Actually, MATLAB interfacing is possible here, right? But I will go with this by default COMSOL multi-physics only, and I'm not going to interface this MATLAB with the COMSOL. It is possible, one can explore that, right? So I'm opening this one. Whenever there are any lag, okay, you should inform me so that I can solve that issue. And if there is any lag. Right? This screen is visible to you, the COMSOL by default page. The
Yes,
model
sir.
is visible.
Yes, visible, sir.
Hello.
Sir, visible.
Yes, please reply. Anyone?
Yes, visible, sir. You can continue.
I'm not able to hear you.
Hello, sir.
Okay. My speaker is.
Sir, it is visible. You can continue.
Yes, fine. Actually, my speaker was deactivated. So, yes.
Yeah, hello.
Yes, sir.
Yes, sir, just a moment, sir. Oh, it's not
Yes.
audible, sir. Your voice is breaking.
Very
Can you
good.
just figure out? Yeah,
Okay.
we couldn't follow you, sir.
Yes. Let me once. Is it better now?
Yeah, it's better, sir.
Yes, fine.
Thank you.
Okay. So, if you open that particular icon which was on the desktop, you will find by default this page. Right? So, on this page, okay, you can see that the new button is there, under which there are 2 icons, 2 links you can see. Right? The model wizard and blank model. And model wizard is a kind of the interface, okay, in which the preliminary settings are there already. And like the physics, what do you want to apply there, you can define your unmodel here in the blank model. But that will require, okay, much experienced person in this COMSOL, so that every variable's compatibility should be compatible with the already inbuilt function of this MATLAB, this COMSOL, right? So we should go with the inbuilt model wizards, and first, if you will become expert in this field, you can use this blank model to design your unmodel, right? So I'm going with this model wizard here, right? If you click here, right, you will find there are several number of the space dimensions. As we know, there are the basically 3 dimensions. That is the 4 dimension, in fact, 0 dimension, 1 dimension, 2 dimension, and 3 dimension. And that is written here. 0 dimension, a dot is written there, and because degree of movement of any particle, or you can say that the degree of freedom is 0, right? And in 1 dimension, degree of freedom is 1, one can move in one direction only along this line. Right? And I will come to this axis symmetry, but before that, this 2D, in the 2D there is a 2-degree figure, and 3D 2-degree figure. As we know all of this, these are the basics I think. Right? So 0D can be for the gas particles, for the nanoparticles, for the quantum dots, like that. And you can model those problems in the 0 dimension. In one dimensional, you can model your nanorods, nanopillars, and wires, etc. in the one dimension. In 2D, there can be the 2D sheets like the disc and very thin disc, and 2D nanomaterials you can model here in the 2D dimension. And for any 2D view of any structure is possible. So if you want to just have a view of the energy distribution in only 2D, and so you can go with this 2D. And 3D definitely defines the 3 dimension, and just like a block can be there or dice can be there. So, but what is this 1D axis symmetry and 2D axis symmetry? Right? If I define in that way, so axis symmetry is, you can see in the picture, and there is an axis, vertical axis is there, and around that there is some symmetricity. Whatever amount is on the left, that is on the right also. Right? This, with respect to this axis, there is symmetricity first of all. Right? So this is the axis symmetry first of all. In 2D, you can also see that. But what is the difference between this 1D and 1D axis symmetry? We should clarify this first. And so, as we know, suppose that we have a cylinder. Right? We have a cylinder, and particular cylinder will have a 4 axis. Right? So, but as we know, the cylinder has its axial dimension as well as the radial dimension. This radial means going in the radial direction towards the axis of the axis is passing through the center of the cylinder. Right? So, if you want to observe only the axial distribution of the energy. Energy means electric field, magnetic field, and current, voltage, anything. Right? So, if you want to observe only the energy distribution along the axis of the cylinder only, then we should move to the 1 dimension. Or we can say that will become the 1 dimension if the radius of that particular cylinder will become very, very less, right? Or very, very narrower. Right? So that will become your 1D. But suppose that if you are not interested in the axial distribution of the energy, rather you are only interested in the radial distribution of the energy. And suppose that the heat transfer case, if some heat is transferring from the iron rod, right? So what will be the distribution of the heat, right? Or what will be the distribution of the current flowing through the copper wire, right? So if you want to observe the current flow through the axis of the wire, then we should follow the 1 dimensional. Whereas if you want to observe the current flow in the radial direction of that particular wire, then you should prefer the 1D axis symmetry. And although you can model that particular current flow modeling in the wire in both of these modules, and 1D or 1D axis symmetry, but the result will vary. And so, 1D axis symmetry will give you the exact result for the radial distribution, whereas 1D will give you the axial distribution accurate result. And similarly, for the 2D and 2D axis symmetry, and in 2D there is no requirement of any symmetricity first of all. Right? So, and in 2D axis symmetry we will have an axis symmetry here. So, I want to say, suppose that you want to observe the radial as well as axial distribution of the energy in the 2D design. Right? So, in 2D, if axis symmetry is not there only in the 2D, what will happen? We will only observe the energy distribution in the radial direction, not in the axial direction. Right? But in the 2D axis symmetry, we will have the axial as well as radial, both distribution we will have. Right?
Yeah, hello, sir.
Yes,
Just a moment, sir.
Yes,
Sir, I couldn't follow you, sir. So can you just rejoin again? So it's not audible.
Okay.
Check with your mic, sir, please.
Sound is not bad. We can. I suggest Balaji to use the headset.
It might be possible that many of us will receiving my voice, but some of you are not receiving. So, can I have a feedback that am I audible to somebody or not?
Yes, sir. I'm using the headset only, sir. So, but still I couldn't follow you.
Okay, let me once recollect myself. Fine.
Yeah.
Okay. Is it visible now? Hello.
Yes, sir.
Yes, fine. So, I was in short, I can say that okay, the 0D, 1D, 2D, 3D, there is not any problem. But with the 1D axis symmetric and 2D axis symmetric, you should be very, very sure that which model you are going to use. Right? For the 1D axis symmetric, only the radial distribution we will have, and for the 2D axis symmetric, radial as well as axial distribution will be there. But in the 2D, only the radial direction, we will have only radial distribution with the energy. Right? But it is not essential to have the symmetric structure. Right? So let us start with this 2D one. Fine. So I have clicked on the 2D. Right? If I go here, I have clicked on this 2D. Right? Okay. Now you can see here the select physics option is there. Right? You can search here for the select, or you can opt from here. And there are number of the physics involved here, like the alternating current, DC current, and acoustics, chemical species transform, electrochemistry, fluid flow, heat transfer, optics, plasma, radio frequency, semiconductor, structural mechanism, and different mathematics involved. And there can be the another physics also. It depends upon version to version, first of all. And if you open any of these, you will find different number of the physics inside that one also in the child mode. Fine. So because I have targeted actually it is a physics part, and so number of physics is involved, and nobody can be expert in all physics. Right? So I have explored few physics domain of it. I have explored in the optics, the wave optics domain. And so you should select as per your expertise area, or the as per your field of interest in which you want to make any device. You can select any of these physics part here. Right? So for example, I am selecting this wave optics, then wave optics. Right? If you open in such a way, in the final node, you will find some options here available. Means what kind of domain you want to select. Means time domain, frequency domain, transient domain, and some other domains are also possible. Like in the wave optics, there are 4 domains. If you go on the wave optics, you will find 2 domains are here: wave heating, geometrical optics. Fine. Suppose the heat transfer, that is well known to everyone. There are many more options are here. Heat transfer in solid, heat transfer in fluids, heat transfer in pipes, and so different options are there, and you can explore that as per your field of interest. And so I am here. I am interested, suppose that, to observe the frequency domain analysis. And so I will click on that. What is the task of this domain? It is written here. Fine. You can read it and justify your selection that is it a correct choice or not. And second thing I want to express here that suppose that you have made any device here, you can observe the frequency domain analysis. For the same device, you can also observe the beam envelope also. You can add multiple physics in your single analysis. Right? So I will tell you that how it can be added. You can add from here also, right? Or you can add after the starting of the initial settings also. And like if I will add this one also, it will be also added. But I am going with the only one here. I have removed one. So I have only used here electromagnetic waves frequency domain. That is the EWFD, electromagnetic wave frequency domain. Right? So I will select here and go for the study here. Right? So you are required to click on the study. You should not be worried what is written here. Right? So you can go with this study. Till now, any problem do you have up to this? Anybody? If you have any problem, one can discuss it. Actually,
Yeah, participants, if you have any doubt, it's better to unmute yourself and ask. So sometimes the chat option, sir cannot access it.
I'm not getting you, sir.
Yeah, please go on, sir. It's fine.
Okay, fine. So I'm moving with this one after selecting the frequency domain analysis. Right? Now, after selecting the physics, what kind of study you want to study? It's like in the frequency domain, adaptive frequency suite, you want to study boundary mode analysis, you want to study for eigen frequency study, frequency domain model analysis. So number of studies are there. You can select any one from here, okay, and you can select multiple from here. As I have explained for the physics part, you can add multiple study from here. And but I'm going with the suppose that the model analysis. And because I will be introducing by considering a simple optical fiber having one core and one cladding only, right? In which we will observe what are the modes there. And I think you all are aware with the optical fiber cable. Right? So that is the very simple example. That's why I considered that one optical fiber cable. Right? So let us see the mode analysis here. Right? So it is done. If you select here done, you will go to the panel window. Okay, once you have selected from there, just see here that I have selected the EWFD, that is the electromagnetic wave frequency domain. And second is the in the study I have selected the mode analysis. You can add another physics and another study from here only. You are not required to go back to select there. And you are just only required to select anyone from there. And you can select here. Right? So let me introduce different parts of this window, okay, which is very essential to operate this software. Right? It might be possible some of you know this, right? But I will target to the very beginner and who is totally unknown to this. Right? So let us see different parts here. First, as usual, with the MS Word, you have seen that there are a number of options on the top, like, and its icons are also given there. Right? That can be adjusted, that can be customized. Right? This ribbon shows the different options which is highlighted here. You can say, or you can find in different options in this window also. Right? So basically, there are three windows, right, which are promptly used. One is the model builder here. You can see the model builder here. Right? Second is the setting. Right? And third is the graphics here. Right? These three windows will always be in front of you when you are working with the COMSOL. Right? Yeah. So in the model builder, whatever you will click here, that's the setting will appear in the setting window. Right? And what structures you have made here in the model builder, it will be appear in the graphics window. Right? So there are many number of options are here. I will try to introduce one by one. Right? So let us see the model builder. Right? We will start with the model builder. Right? So actually there is option of here collapse all and expand all. So to collapse all, it will be all the options will be all the child node will be disappear, only the parent node will be there. Right? So if we click on the collapse all, we have seen that there are global definition, component, study, and result. And these are the different sections. If you expand, all of the options will be expanded. And so you can use promptly these options to collapse on and expand on. Fine. These two options are available here. Fine. Now, first of all, before moving ahead, we should save our file. So you can save as usual. You have done with a number of the softwares. Fine. So I'm saving it. I just suppose that the day one of the function in this. So this is saved here, .nps file here. Right. So this file name is sorry here. Right. Now, if I start with the global definitions, in the global definition only two parameters are there: the parameter and materials here. Right. Another can be added if you right click from here. Right. Another can be added, but by default there will be two parameters. The participants who have installed the COMSOL, one can go simultaneously with me. Right. So if you click on the parameter, in the setting window, you will find there is a row and having different columns: name, expression, value, and its description. Right. So suppose that I want to design an optical fiber. So is anybody here who does not know optical fiber? Anyone? If one is not familiar with the optical fiber, please reply if anybody is unknown to the optical fiber. Okay, so I'm considering that everybody is okay. Have basic idea of the optical fiber cable. Fine. So it has a core and it has a cladding, cylindrical cell. Fine. So just I'm considering here. Suppose that A is the radius of the core. Fine. So expression will be its numerical value I can give. Suppose that that is the 8 micrometer. Fine. For writing the micrometer, and you should use the square brackets. And for micro, you should write U and M for meter. Right? And close the square bracket. Fine. So if you once click anywhere, okay, it is not taking the value here. Okay, in licensed version or in many softwares, it is taking the value, but here it is not taking. This might create problem for the beginners. Right? So what we should do for that? A, U, M, then press enter from your keyboard. And if you press enter, it will take. I have pressed and found that it is taking the 8 micrometer value. Any unit you can give in the expression, but in the value, it will take the MKS system. Fine. Meter, kilogram, second system, it will display here its value. That is the 8 into 10 power minus 6. 10 is represented here as a E. Right? And its description is up to you. You can mention or you cannot mention. So suppose that I'm mentioning it is what? Radius of it is up to you. You can expand it and plot it and so that it will have a large view. Right? Second is the B. And in the B is the, suppose that the cladding, right? So I am taking 125 micrometer. It is the standard size of any optical fiber, single mode fiber. Right? And I will present here, and it is only in comment I will write radius of cladding. Right? And what else we need? For the structure point of view, we will need this one. And what else we will need? We will be needing, right, the its refractive index, materialistic property. Right? So suppose that N is denoted as a refractive index, and for the core I am writing N core. Right? N core. And for the N core I am writing, suppose that constant refractive index, that is the 1.45. For example, right? And I will write here that word refractive index of the hole. And second, I will write here the uncladding. Similarly, uncladding. So I should not write all. Instead, I should write only unclad. Right. So its refractive index should be little bit lower than the encode. So I will write here the 1 point. Suppose there are the 4G. Right. And I should write. I will copy it and write it. And it is the right. Now I can toggle it, and from here I can toggle it, dock it, and it is here the parameter. And with these 4 basic parameters, I will proceed. Fine. If you go for the wavelength interrogation, suppose that you are varying the wavelength, then this encode and unclad will not be constant. It will have some dispersion relation. You should enter here the dispersion relation. Fine. So let us see. And in the material parameter part, I have entered this one. Fine. Now in the material part, okay, we will not enter here the material part, right? But just you can add some materials here for your model, but I will add the material in the later on. Right? You should not enter the material here. You can add, but you should not enter. Right? So when we should enter here and when we should not enter here, it will be clarified just after, okay, later on. Right? So this global definition part is completed now. Another options are also there, but I will explore it later on. But currently, I am just trying to demonstrate the optical fiber functionality. Right? So let us see here in the component section. I have collapsed it and now expanding the component section. In component section, there are 4 to 5 parts: definition, geometry, materials. I will add material here instead of this global material. Right? Material and this physics part and then mass part. Right? So let us starting with the definitions. Right? So in the definitions, okay, the boundary system is given there and view 1 is given there. XY view. If you are going for the 2D simulation, because we have said the 2D simulation, so by default it is the XY. Right? So this horizontal axis is the x-axis and vertical axis is the y-axis. So this plane is working as an XY plane here in the graphics field. Fine. So, but with this default definitions, I will move to the geometry here. And now in the geometry, I will right click here. If you click on the geometry first, without any right clicks, normal click, left click, and you will find this settings here. Right? So what settings you should do here? And just change this unit. And by default unit, this meter is using a meter and meter. And you can see here the meter and meter. But our structure is such that it is in a micrometer. Just you have seen that I have given the radius of the core, that is the 8 micrometer, and radius of the cladding, that was the 125 micrometer. And so in place of taking the meter, we should take the micrometer, that will be better, and for the visualization point of view. And all the angular units will be in the degree. You can select in the radian, but I have selected in the degree, that is more convenient to understand. Right? So with this setting, this would go. Tolerance you can select relatively or absolute, but I'm going with the automatic. I am just explaining you the simpler settings. Right? You can go more beyond in that for more specific settings. Right? So what are the essentials? Just I'm targeting this one in the first place. Right? So after setting this micrometer here and degrees for the angular, right? So I will right click here and will try to add some geometry for the optical fiber. So there are a number of geometries available, like you can see circle, ellipse, rectangle, square, polygons, interpolation curve, line, parametric curve, point, polygon. Number of curves are available, and you can also import some another geometry also, which is not here. Right? So I will choose the circle because for the current cladding we will be needing the circle. So suppose that I am taking here the circle. Its name you can change here. Suppose that I am going to prepare it is a in the setting window you can see you can change the label. Its name will be changed. Right? So just use this core here. Right? Means we are going to draw the core. Right? So core and that should be solid. Right? So I have selected the solid here. Solid material is here, not any curved kind of thing. Right? It is solid material. Right? Its radius is given 1 here, but we have already defined the radius as it in the global definition here. Just see, in the parameter we have defined the A here. A is the radius of the core. Right? So we will write there the A in this. So I will write here A. Fine. So I have written A there. And its sector angle, you know that having a radius, we rotate it with a 360 degree, it will make a circle. Right? So this circle is found here. Right? And there is two options of positioning, center and corner. And center means just see this plane, the 0 is there and 0 is there. So center of the circle will be at the 0, 0. But we place the corner, right? A corner, you should define the x and y value here. Where you want to put the corner, okay, it will adjust automatically. So let us see by the center, and center is at the 0, 0. You can set as per your structure, but I am simply taking the 0, 0. Right? And just click on the build all object. For a single object, you can go for the build selected. Right? So this you can see in the graphics part, a circle is there. Right? So similarly, we will go for the cladding part also. Right? So right click in the geometry, right? And select the circle once again. Right? And write it is a clad. Right? So after adding the clad, it is also a solid, right? And its radius will be B. We have defined in the parameter section. Right? So it's a B, 360 degree rotation. It is also with the concentric, because in the optical fiber, core and cladding are the concentric. So center of the both core and cladding will be same. So I'm taking here the 0, 0. Right? And now if I will select the build selected, and so it will build this one. Right? And build all object will build all of the previous objects whatever you have inserted. Right? So this should select only the build all object that will build all of the geometries whatever you have inserted here in the graphics window. And so you can see that core is totally observing to us, but cladding is not. Why that is so? Because you have taken the scale here from -10 micrometer to the 10 micrometer, and on the y-axis -8 to the 8. Right? So it is just zooming the core part only. Cladding is not. You can treat it from here. Zoom, extend. Right? Click on that, you will have this view. Right? The central part is the core, and this outer is the cladding. Right? So you can. There are 3 or 4 options of the zoom. You can see one is the plus. Click on the plus, it will zoom as usual we use. Right? Click on the minus, it will reduce. Right? Okay. And if you want to paste, if you want to have a paste view, normal view, you should select on this. Right? It will give the full view here. Right? Now sectional zoom is also there, zoom box, and by clicking this, you can drag here which portion you want to zoom. Suppose that I want to zoom here, so I will select this portion, it will be zoomed. And just simple right click here. Click here and then right click and drag. This portion will be zoomed. And so that can be used. And zoom to selection. You can move it. Fine. Okay. So further portions will be covered when we will have the result. And so I'm going further. And core and cladding we have defined. In the simple optical fiber, we will be needing only the core and cladding part. Right? Rest nothing we need. And now next part is this form union must be there. Fine. It should not be deleted because it is forming, means it is uniting all of this component whatever you have inserted here. So it should not be deleted, otherwise it will create a problem. And now what is there in the bracket? C1, C2, here component 1. These are the variable for this code. If you want to use this geometry in anywhere in the further, and you can use C1. C1 is for this code. And so we will learn this, how to add two geometry, how to subtract these two geometry, multiple geometries, how to copy them, and in further lectures. Right? But I am going just forward. And so let's, after completing the geometry part, we should go for the material part. And right click on the material, you will find there are many options. Add material from the library, browse material, blank material, material name, and others also. So blank material you can select and you can give your unproperty from there. And suppose that I'm clicking the blank material. And so in the blank material, and there are different material one. So suppose that I'm going for the code. So I have written a code, level code. And it is a domain set kind of thing. It is a domain kind of thing. Let us see. So domain and boundary and point is also there, but both surface core and cladding are the boundary and domain. So we will select the domain. Which domain we will need? Right? So they are right. There are two domains. And in this version, it is not showing the geometry yet. It should show. Suppose that I have selected 2. Right? It is not giving here because line material. So I am omitting this because geometry is not showing. Maybe just because of this version of the COMSOL. I am deleting it. So I will go for the add material from the library. Right? So I am clicking on this. Right? So here one new window is open when you click there. Right? So in this you should go for the SiO2. Click after. Right? SiO2. Okay. In this there are number of SiO2s. You can say. And like solid part, SiO2 fused quartz solid. Right? So I will take this one. Suppose without going in much detail, I am selecting just one solid silica fused quartz. Right? So either right click and add to global materials or add to component. Basically, I did in the add to component, and for double clicking, you will get here. I am double clicked. Yes, it is appearing here. You can see under the material, it is there. Right? And if you click on this, you will find the lots of properties here. Right? Lots of properties you can see here. Like for this material, the thermal conductivity, the resistivity, coefficient, weight, and like all. Right? But we are not getting any the refractive index or anything else. Right? So we will go for the material property from here. And you can add number of properties from here. And so I'm going with the basic property here. And in the basic properties, and I am taking suppose that the refractive index somewhere if it is there. It is not there. Relative permittivity is there only. Relative permeability is there. You can opt that also, but in another section you will find that index also. Let us see this in the semiconductors. Showing material parameter. You should explore each one. It should be the optical properties there or not. Let us see. If it is not taking, we can go with the permittivity also because permittivity is equal to the square of the refractive index. So I am opting that one. If it is not there, right? Relative permittivity. It is there. You have to search that. Right? So if you once double click it, it will be added to the property. It is not working. Why that is so? Are you people getting or not?
Yes, sir.
Yes, correct. So I'm trying to add it, but it is not adding. Maybe just because of it. And also the geometry is not visible here. This is the big problem. Suppose that I'm deleting and trying to once again. It is added here. It was working earlier, but the geometry also making what happened with this used to it is a very, very simple actually. Let us see. Then that. Yes, it is not. Actually, we have not built that one. That's why it was not there. On the geometry, we should select the build all. Then only it will appear in the material section. Right? Now, right, I am deleting it. And we again entering this blank material for instance. Right? If you add the blank material, right, you will have lots of properties similar to that. Now it is asking that I have, let us see once again for any confusion. And again adding that. Suppose that I have deleted previously, and I am adding now this blank material. Right? Now you will see that by default there is two properties: refractive index, real part, refractive index, imaginary part. Refractive index, imaginary part is also known as the extension coefficient. Right? So that is the complex refractive index, like the 1 plus 2.5 I. Right? So I am writing here the real part is the N4. N4 we have defined in the what kind of style it is taking. It is not taking. It is not also deleting edit and some another language it is taking by default. I have not heard earlier on this area. No issue. I can give us by default any numerical value. It is not also taking. Some references are there. But you're doing once again. And instead of the blank material, I am going again to the library, right, and using this solid, this one. And this reflective index is asking here, I am trying to write here once again, N4. It is not taking also here. Just we are facing the problem just because of this writing style. Why it is happening? It should not happen actually. It has not happened that way. You can see that multiple options are selecting. It is behaving unexpectedly. Or you can't. Already is getting disturbed. Okay, let me save it. And I'm restarting this once again. System is. Please wait, please wait. System is not there. What did you say? I'm reconnecting myself. Please wait. System is not there.
Please copy tell me that I will it requires consistent continuous.
Sorry for the interruption. The system was not working. Probably it should work. Now. My screen is visible. Anyone please reply?
Yes, sir. Yes, sir. Your screen is visible.
Fine. So I'm restarting that particular what I have said. I love the system was not working. I don't know why. Hopefully all three was said. Yes, geometry said no issue with that. And in the material, we should start with the blank material, primary material. So let us see it is taking once again. It is now taking, right? So and co, right? So we have to enter it. And so enter. Right? And this refractance in this part will be 0. So I'm entering 0. Right? So for which part you want to give this material? And core is the core part only. Right? So just this is selected now both part. I am just deselecting one part. Just check this. I have selected one. One is your what? Core. Sorry, cladding. Just see. I am clicking on one. It is highlighting the part in the graphics. Right? So there are two options to enter the domain on which you want to apply this particular material. Right? So by clicking this paste selection, okay, you can enter your the domain number like 1, 2, 3 like that. Right? And second is that by just clicking here in the geometry, select deselect, right? Select deselect. Right? So I want to apply for the code just why the two I have selected here. If you click on this, nothing is selected now. You want to select, just click on the code. Right? Simple. And in place of domain, okay, you can go for the boundary also. So you will see also how the boundary is selected, and you can go for the manual or all domain. If you select for the all domains, it will take all the part of this geometry. And but we are not interested to give the same material for all the parts. Right? Rather, we want to give only the core part. Right? So I will remove this. Okay, cladding part here. Only 2 is there. Right? Similarly, I will add one more material. I should name it first core. Okay. I have added to the core. And its name is change here. Now I will add another blank material. And that is the clad. And in the clad, domain will be there, manual and the cladding. We should write here what? N clad. Why we are taking N clad? Because we have already defined it. N clad. Right? It is predefined in the parameter section. You can see N core with N clad. It will take its value 1.45, 1.40 from here in the global definition we have taken. So clad part is also defined here. Right? So material part is completed now. Right? Now we should go for the physics part. Right? This is the physics part here, actually. Right? So this is the main part of your whole study. Actually, this is different for different structure, for different physics part. Right? So you should bother about this. Right? But we are going with the by default setting here. So just click on the initial values. On this wave equation here under the EWFT here. You will find lots of settings. Right? And this wave equation is applied to both of this part of the geometry, 1 and 2. So this is 1 and 2. Right? So coordinate system, you can go for the global coordinate system. Right? And many more are also there. And refractive index, refractive SMSB part, all are taken from the material. Right? So I am going with the by default setting. Later on in the next lecture, okay, we will try to reset it, right, as per our requirement. Right? So if you click on this one, you will find here the 3-way vector and in-plane and out-plane vector. So these are actually for the polarization. So I am P polarization, TM polarization, T polarization. So here I am going with the 3-component vector now, right, by the default setting. Right? So we will try with the default setting, right, and we will change it in further lectures. Right? So one more thing we should add here. Okay, the boundary condition here. It's boundary condition here. So for that, we should enter one new material here. Okay. Enter one new material. What is the importance of the boundary condition? Actually, we try to do not disperse the energy out of this geometry. We try to capture the energy inside that particular geometry. So, and again taking a new material here, blend material, and its meaning as a boundary. Boundary. Right? Suppose that. And it is a kind of a boundary. So I should select here what? In place of domain, we should select the boundary here. And I will select all the outer boundaries. There are inner boundaries also there, but we are not interested in the inner boundaries. Rather, we are interested in the outer boundaries. Okay. So I have selected these outer boundaries. Okay. So 1, 2, 4, 5, 8 is the boundary number. Okay. So material for this is, we should add the property from here, but instead of adding the property, you can add from here. You can add from here, but I think we should do the same material which is adjacent to the boundary inside the geometry. Right? So cladding is the material, so we should do the material for the boundary as well, whatever the material we have assigned for the cladding. So because material is property is not mentioned here, so I am deleting it, and I will copy this clad and duplicate it, and now I will name it as a boundary. And domain, in place of domain, I will select the boundaries simply. Okay. Now all the boundaries selected, material is enclave. Whatever the material for the cladding, that will be same for the boundaries, outer boundary. Right? So for added this material, we have to add here some boundary condition. So I have suppose that inserting here the scattering boundary condition. How this open? Just right click here in the EWFT link. You will have the lots of options here. And so out of those, there you can see that lots of boundary conditions are also there. Different boundary conditions have different effects on the controlling the energy transmission out of the structure, or to control the energy transmission from going outside the structure. Right? So by default, suppose that I am taking the scattering boundary condition. Right? You can go with the different. You should first study this boundary condition, and then you should decide that which one is better for your structure. Right? So for your physics. So on the basis of your study, you should add here. So I am adding here the scattering boundary condition. Right? So scattering boundary condition. So I am selecting the boundaries here manually. These boundaries I have selected. Here we have applied a scattering boundary condition. Right? So now after applying the scattering boundary condition, with by default setting here, right, I will go for the meshing part. Right? In the meshing part, we can directly build all the meshing with the physics control mesh here. User control mesh and physics control both mesh are here. Right? And element size is there, extremely fine, extra fine, fine, or fine to the coarser. Right? So suppose that I am taking the normal. What is the impact of this meshing? Okay, I will be explaining on the further lectures that if you take extra fine means the elements are very, very, very near. So what happens? It will take lots of time to run this to compute this structure. Right? So I am taking it the normal, not very coarser, not very fine. Right? I am taking a normal one. Right? And suppose that I am trying to build all by the bar default setting. There are a number of settings. You can do different element size for the core and cladding board. And for core, we need, suppose that is the smaller area, we need some smaller element size. For the cladding, we will be needing the larger element size. And so that is also possible. I will do that, but we are trying with the same for the core and cladding. And let us see if it will do or not. Cladding, I'm messing. Okay, it is not doing. It is taking time. It will do definitely, but take time. So I am stopping this one, right? And now I am trying to add some here the element. Here, if you right click on the mesh, you will find there are number of shapes to element it, like the triangular, quad, map, and many things are also there. Right? So suppose that I am taking the free triangular. This is the very famous one, which considers the corner one also. Right? So let us take this free triangular, and I am by right clicking on the free triangular, you can add the side. Right? So suppose that for the free triangular, and I am taking the entire geometry. Entire geometry means all geometry. Right? And this size is normal here. It is controlled normal. And you can define as per your customization here, but you have to give maximum minimum size and other options also. But by default, I'm going to do 3 different. And now I will mesh it, build out. So you can see this meshing part here. It will automatically adjust the size of the element as per a requirement of the area. Right? So this was the thing that is why I was saying that the COMSOL is working on the finite element method. Right? Just see the cladding part. In the cladding part, it has divided the cladding part in a smaller triangular area because we have taken the triangular mesh. Right? So it has meshed. And in the core part, there are very smaller triangles are there. And at the boundary of the core cladding, there are more and more number of the meshes are there, because on the boundary it needs more and more elements to define the energy transmission from core to cladding or cladding to core. Right? So if you zoom it, and I am zooming it by clicking the sectional zoom, and you will find that let's see. It is the core part, is the cladding part, and it is the boundary of the core and cladding. So just you can see that the element size near the boundary are smaller with respect to the away from the boundary. Right? So on the basis of these boundaries, it will apply boundary conditions. Suppose that, right, it will find the energy from here. So this part of energy, how it will go to the next element, okay, it will apply boundary condition. Right? So what is the boundary condition? It is already inbuilt in this. Okay, you can go with the physics literature for that one, but it is already inbuilt. Here, we should not be worried about that. Right? So after having the meshing part, we should move to the study part. Right? So today I'm just giving some brief only, and in much detail we will be explaining. Right? So this component part is now completed. Global part we have completed. Now component part is completed. Now we will move to the study part. In the study, right, I have added the mode analysis initially, but you have a number of options to add here. Another study. Just see, if you right click on the study one, you will find that the many number of the study types are available, stationary and that all, which you have seen earlier. Right. So anyone you can select here, but suppose that I am going to the mode analysis here. Right. So right click on the mode analysis, you will find that. And you will find that there are a number of options here. And so here are the transform methods. You can go with the effective mode index here. You should go with this one. What is the use of another one? I will be explaining, but today I will go for the effective mode. Actually, effective mode index is nothing but the effective refractive index. We have considered the coarse refractive index 1.45, whereas for the cladding it was the 1.40. So what is the effective? This combined refractive index of the whole geometry, that is the effective mode index. Fine. And it is the mode analysis frequency, that is the C by lambda. C constant is the by default variable for the speed of light in meter per second. Fine. And one is the wavelength of operation. So for the communication purpose, as we know that 1.55 micrometer is the standard frequency. So I will select here 1.55, 1550 nanometer, right? 1550 nanometer or 1.55 micrometer. The wavelength I have selected. Right? Now we will search more manually, or you can go with the another options also. Right? So for the manually, suppose that we are targeting for the 6 nodes. You can enter the 100 nodes also. Right? But it will take lots of time, so I am taking only the 6 nodes. Right? No need to define the unit here, and because we are targeting the effective mode index, and effective mode index does not have any unit. Right? So where you want to find the mode, means where you want to find your energy to be concentrated for the communication purpose. Everybody knows that for the optical fiber communication, the energy should be confined inside the core one. So we will insert here the core's reflective index. So we will write here the N core. Right? So we are searching the mode inside the core. If you change it, the energy distribution will change. You will observe it. Right? Rest all settings I am keeping by default. Okay, there are number of settings. Right? So we can explore that, but in single lecture it is not possible to explore all of those. So I am going with this nominal settings here. Right? Now it is time to run it. Right? So for running it, just click on the compute. Right? Compute here, or there is a green triangle here. You can also compute here. Right? So let us. I am computing from here. It will take very many time. Yes, it has computed and given some result, electric field distribution. Right? So you can see the electric field is here. Right? It option comes just after running. Right? Another many options are there. We will add that one by one. But let us try to now just see the field distribution. I have selected 6 modes, but here we are observing only one mode. Another can be you can go with this arrow back and forth. Right? So I'm going forward. So this is the next mode. This is the next mode. Just observe this light distribution inside the core. Right? This one, this one, this one. All of these 6 modes later. First, last. So it will be better if I zoom. It will be better observing. And I have zoomed. And just observe the different light distribution. This is the correct one actually, because light is concentrated in the towards the center, and when we are going outward from the center, its light intensity is decreasing. Just observe with this scale graph. That is from 0 to 300 plus. Right? In the core part, the maximum light is concentrated, and when we are going outside the core, means away from the core in the radial direction. Right? So what it is giving? It is giving what? The intensity is giving. Intensity is getting decreased. Right? So this is the what field distribution or energy distribution inside the geometry, inside the R geometry. This is the whole. Right? And you can zoom it as per the view. Or you can right click the mouse and drag it. Right? And right clicking and then right click or scroll it. Scroll it by right clicking and scrolling, it will zoom in and zoom out. Just try by yourself. I will further explain this one. Right? So this is the field distribution. Which field is this one? You can check it here in the surface one. In the surface one. Okay. That is what surface one. That is the EWFD norm. It means electromagnetic wave frequency domain. It is the physics part. Dot. Actually, any inbuilt example can be defined with this EWFD dot, and then the variable. Norm is the inbuilt variable. Norm is normalized electric field. Norm E stands for equal to under root of EX square plus EY square. And, sorry, under root of modulus of EX square plus modulus of EY square. And that is the norm E. And this field is we are observing here. Right? So this was all about the field. Number of operations are also possible in this field. And let us number of options are available here. We will study one by one and in further lectures. Okay. So I think for today's it is sufficient. And so, but how these results will be analyzed, and how we will have the 1D plot from this field, right? How any table can be, data can be extracted in the table in the form of accessing. Okay, this is the further part of the analysis of this result. Okay? So today I have just tried to give a very basic example so that you should be familiar with this. Okay, software, at least how to operate. Right? So we have covered the global definition, component, specific result, with the default setting and very minimal basic change in the settings. Right? So, but remember that if you're going for the very real problem scenario of the today's world, of the current days, you will be doing lots of in the settings, right? In different parts of the of this model builder, right? So, if any problem you have, you can discuss today, right? And rest of the things will be explored in the next lecture. Anyone?
Thank you so much, sir. Yeah, thank you so much, sir.
Welcome, sir. If anybody is feeling any problem anywhere, one can discuss it. And I think it will be better if you do simultaneously with me, because you know that time it is a kind of a hands-on, so that's I have gone through very slowly.
Yeah, so we will give the recording, so later also they can do it.
Okay, fine.
So our request is we will give the recording. So before tomorrow's session, please do it and be familiarized with the platform. Maybe very easy for you. And of course, once you did, then you have any doubt. So even if you don't have any question today, tomorrow please ask, put in the chat box or unmute yourself and ask it.
Yes, of course, one can paste in the chat box. I am observing that.
Yep, if they don't have any doubt, then we can wind up today's session and we can meet tomorrow. Thank you so much, sir.
There is not any issue.
Yeah. Okay then.
Okay, dear participants, thank you for your today participation. We expect your participation tomorrow also at the stipulated time. On behalf of the Department of Physics, Nanjal Catholic College of Arts and Science, I thank Dr. Jitendra Mayura also and the organizers also. Thank you very much, dear. Have a cool night. Thank you very much.
Thank you, sir.
Thank you, sir.